stream. Hope you're doing good. Hope you're having a good day. Another day, another video. And as usual, this is Code Row, and today we're going to solve some lead code problems as we're doing every day. So today we're going to solve some lead code problem about the binary tree BFS, which is breadth first search. We did binary tree DFS, and today we're going to do some BFS lead code problems. So we have these two lead code, but before that, don't forget to follow me on GitHub. You can find me also on LinkedIn or on Instagram. I will be so happy to connect with you. And recently we did a Discord server. You are free to join it. And without further ado, let's go to the problems. So now we're gonna do the binary tree right side view. This problem is about the Hulk. Today's theme is about the Hulk's rampage and redemption. The first problem is gonna help us to smash through obstacles and see the world as Hulk does from the largest, most impactful view. So, without wasting more time, let's bring back our and let's go. Okay. So the first problem is about binary tree right side view. Okay, so given the root of a binary tree, imagine yourself standing on the right side of it. Return the value of the node you can see ordered from top to bottom. Okay, so 1, 3. Oh, okay. Okay, I see. Okay. So I think this is not that hard. Let's bring it to our output here. So here we have a normal root. We have a normal binary tree. We're gonna act like we are standing in the right of it, and we will have to return the view. So every node we view it, we're gonna return it, and every node we can view it from the right. It's gonna block the left one. So if there is a node here, so it's gonna block this one, so we're not gonna see it. Same thing for this. The 4 is gonna block the 5, so we're gonna see it. So finally we have to return those nodes. Okay, and same thing for the second test case, but in the second test case we have nodes that don't block other nodes. So here the root, we're gonna always return the root. So the root is the first node that we're gonna see. This is blocking this, so we're not gonna do it. And there is no node, so we're gonna look to the 4 and then the 5, and as a result we're gonna return those. Okay, so mainly we're gonna focus on the right nodes. I think it's a okay, and okay, so we're gonna use a queue. I think this is the best approach. We're gonna make it recursive as a DFS. There is no difference. We're gonna use a queue, and we're gonna append the left and the right, but we're gonna only okay, so I think now we have to use two queues or two okay, let's make it like this. We're gonna use two queues, one to append all the element and one to only show the right nodes. Okay, so let's define our DFS or our BFS. Our BFS function. Okay, we're gonna iterate through all the binary tree, and then we're gonna append all the node of the same level to a queue, and we're gonna initialize another stack or another list to return it. Okay, how is gonna do this? Let's define our BFS. So here def BFS, and it's gonna take self and root. So if not root, then we're gonna stop, and then as usual BFS of self.bfs of root.left and self.bfs of root.right. So now we are iterating through the and here, okay, iterating through the, okay, and here BFS of root. Okay, so so now we're gonna iterate through it. We're gonna make every node in a queue. So how is gonna do it? Okay, so let's do it here. We have to initialize it first. Okay, so q1 equal, I'm gonna initialize it with the empty list. And we have to make it here. Okay, so q1. Okay, so q1 dot append root. So now we're, hey, welcome stream, man. I'm from Tunisia. It's a North African country. So we append the root. We're gonna append it all. Okay, I'm just gonna check for the q1. Okay, and here we have to make it also. So q1 and here q1. Okay, so BFS is not defined. We have to make self. Oh, root to q1. Okay, so it is going good. Okay. So iterate through the binary tree. We already did this. Append all the nodes at the same level. We already did this. And initialize another list to return it. Okay. So I'm gonna call it final. But the final is gonna take only the 3, which is the why okay, So how does this look? So 1, 2, 5, 3, 4. Okay. So the 3 is the second one. So here is I'm gonna iterate 1, this 2, and for this it's also 2. أيام مريضة ولا فيش. Okay, so we return it 1, 2, 1, 2, 5, 3, 4. Why we're returning this? One, 3, 4. Okay, so 1, 3, and then 4, 2, 5. Why is it going like this? Okay, so every time 1, 3. Okay, so and the second 1, 3, 2, 4, 5. Okay, and is there another test case? So the test case 1, 0, 3. Okay, so so can I make it here? I want to see the difference here. Okay, so 4, 3, 2, 1. No, it's not good. I'm just gonna place it in a different position to see the results. So it doesn't make a difference here, so it's gonna just do it here. Okay, so now we have 1, 3 for the first one, 1, 3, 4, 2, 5. Okay, and the second one we have 1, 3, 2, 4, 5. So the first, the second, the third. No, the third is here. Okay, so I want to see the Q1 every time. So print Q1. So now we have 1, 3, and then 4, and then 2. Okay. So this is gonna be the result. Okay. Then 1, 3, 2, 4, 5. So if there is a so I just want to see the BFS, not for graph, for a binary tree. Okay, so hi. Okay. So every time we're gonna make the level. If the level is high. Okay, so if level equal 1, and what is this for? So I'm gonna add the level, I think. Here we're gonna make level plus 1 to know where, or level plus 1. And I think every time I'm gonna append the level to the final. So like this level 1, so I'm gonna append this level 2, and the right is the second one. We have to make the right is the second one to make sure that okay. So okay, let's erase this and that, and let's go. Okay, so 1 2 no, this is not going well, so it has to move like this: 1 2 3 and then 5 4. How we do it? 1 2 3 and then 5 4 4 5. So he is doing it. So print for range. Oh, so it's not recursive anymore. Well, it is recursive. Is there a queue? So queue dot append root. Okay. And while. Oh, so he's using a while. And that will be 1 2 3 4 5. It's 1 2 3 4 5. Yeah, this is what we need actually. So so yeah, I think that can be good. Base case. Base case for what? Is he even using it recursively? Okay, so let's just that, and I'm gonna make all of this as a comment, and I'm pushing it. Let's push this here. Okay, so we're creating So append root, if root, this is have to be like this every time. Okay, so q0 dot verb, q dot verb, not the left, not the right. Okay, so okay, 1 2 3 and 5 4, and for every level, so this index is 0, so it is level 1 or level 0. This is level 1, and this is level 2, and this is level 3, and this index is 4, and this index, okay, I'm about to make it. Here also is 1 3 4 5, here it's 1 3, so here you have a queue of queue of 1 2 3 5 and 4. Let's call this level 0. Index is 0, and it is okay, level 0. This index is 2, and level 1. Okay, how is gonna do it? Level 1, and this is level 3, which index is 5. Or every time we append like 1 2 3, we're gonna pop the last element. So I think so, not q dot pop if node level is not node, q dot append not left, not right. Dot append root, and root, and then I'm gonna make so I'm gonna define a new list equal res, and the res will be q dot pop. Res is gonna append q dot pop, or and then I want to print this out of range. Okay. Node equal q dot pop. So why? Oh. Okay. Node. Okay, so this dot append node. Okay, I'm gonna try it with node dot var. Okay, so 1 2 3 5 4. How to just append the last element? Q dot append rest of the pant. How am I appending? Q to the pant not left, Q to the pant not right. How am I appending all of this? I just want the... So, 1, and then 1, 2. Why am I appending the 2? Okay, append, and all of this, or can I just, if I make it here, is there a difference? Okay, 1, 2, no, there is no difference. So I just want to pop every node val, and then I don't know why I'm okay. So len of q. So there is already a q for level. While the q is when it's gonna stop. It's gonna pop every time. So I'm gonna make it by level. So this, if so I'm gonna increment I equals 0, and the len of the queue here so okay, so on the first the level is 1, on the second the level is 2, but here the level is 3. The level is 2, but the 3 we have to print 3. Okay, so it's level plus 1. If there is already a queue. Okay, so this case here it's 4 and 5, 3. But here is 2. If man, it has to be simple, but how I'm gonna know if so if the node has if this node has 2 children, then I'm gonna wait. If it's not, then I'm gonna print. Okay, so if node dot left, if node dot left exists, Then I'm gonna continue. Can it be? Okay, on. So if not that left. Okay, so the left I'm not gonna append them. I'm not gonna append the left. So so rest. I'm only gonna append when the next time. So oh, okay, let's try this. Not. Okay, so 2, 3, 5, 4. Okay, so this is not good, looking good. 1, 3, 6, 4. Okay. So let's just check. Can't I work it with this? Like 1 to 5 and 3. Or do I have so I'm gonna run it for the last time and see how to, like this, D2. Okay, I'm not gonna append 2. Why? Because there's already a left. So if there is a left at level 2, if it has, so I'm gonna print if it has right and left children. I'm gonna print if there is no right. If there is no right, then I'm gonna print the left. Okay. Okay. Right. So okay, so we will end this. So if not left is not none. Is left. I'm just gonna see a hint. I was gonna use the recursive. Okay. So right is equal here, right dot right and left, and then he's gonna return root val plus right plus left. Root value equal 1, and then the right equal the right plus left length of right. computer. This can be. Okay, how to do this? Oh, it's incorrect. Is it really incorrect? Not root. Okay, so it is correct. But okay, just explain it. Okay, he's just gonna make the right and the left, and then he's gonna return every time, or not every time, in the last he's gonna return the root dot val. In this case, like in this case, it will be 1, and then right, and then right, and then left of len right until the end, which is left will be len of right. This that will be 1. Oh, there is no 1. Okay, so it's a pretty good solution actually. Okay, now let's go to the maximum level. So the maximum level will talk about measure the intensity of Hulk's rage at each moment, identifying where his strength peak. Okay. Just want to see the recursive way of the DFS. And this is fucked up. The BFS. So 1, 2, 3. Okay. So push. While why it is always working with while. Can't I work with it? Okay, so I think I suck in this DFS thing. So given the root of a binary tree, the level of its root is 1, the level of its children is 2, and so on. Return the smallest level x such the sum of all the values of node at level x. That's maximum. Okay, so level 1 sum 1, level 2. Oh, you're just gonna sum it and then return the max sum. But this look easy. Okay, I'm just gonna try this solution. Okay, and I'm gonna make it in a list. So I'm gonna define another one. So let's define it at let's make it here. Def DFS self and root. So if not root and this is BFS and this is BFS, and I'm gonna append q dot append dot this. I'm gonna make q. This is q equal and BFS of root and q, and here I'm gonna every time I'm gonna print q. So print root, print q. If we have to, okay, so the return BFS, self BFS always, self.bfs. Okay, so q. I don't think we even need q. So gonna make it dot file to okay, so 1 0 1 0 7 1 0 minus 8. One, then 107, then 107. So after this, we have to sum the level. Every time I have to sum the level and then compare it. Okay, so the level 2, it's from 7 to 0. Level 3, so I'm thinking of, for example, okay, so let's say we have this as a result. Now it's 1. Then it will be 1 0 and 1 0 7. And then is in this level 1 0 7 minus 8 and 1 0 7 minus 8 and 7. So the number of roots here, if here will be like 5 and 4, then will be 4 list. So I'm just thinking of taking the last number of the previous level and then sum the after it. So we're gonna sum the minus here is 0, so here it's 7. So we're gonna sum minus 8 and 7. How are we gonna do it? Or can I can I make them in a if for can I make a list for every level? So can I make this? And then in every level, and then append l.append root.val and print l. So we don't need this. I think we don't even need that. Okay, I'm gonna test it. So 1 0 okay. So here not he will print and then level. So okay, so I'm gonna make the level think. So if the level changes, then he will start adding. So if so here the level will be 0. Okay, let's make it to 0. And here level, here also is level, and here we have to make a condition. So I'm not able to think properly. So we will have two variables, which are sum and max sum. So I think we'll have max sum and sum. The sum it's gonna sum for us the root. I want to print here. Okay, so file. I want to print here. Print the L and none of L. Okay, so I'm gonna make it L. Append and L. and here it's L. So now it's 2, then 4. Should be here. So 1, and then 2, and then 3, and then 4. Like when the sum is changing, when the level is changing, it has to no, doesn't. Or we make a loop for, and then another 4, and then we increment every time the so here will be 1, here will be 0, 0 plus 7. I'm not getting it. So I'm gonna try with the condition if level equal len of root, then I'm gonna append to the maximum to the sum. Sum 1 plus equal rooted for null. Hey Kay, hello. How you doing? How's your day? And then if you have to also max has no len. Oh no, len of L. Okay, so the max sum it's a node object. You need to store them in a list. Yeah. Okay, so I make a sum also? Oh yeah, yeah. I'm performing DFS, but uh, yeah, I'm performing BFS, but DFS, but I'm really not that based in the BFS, so I have to make a while. So I have to make a while to averages. And I really don't want to work with a while loop. Want to work at it recursively, you know? Thank you. So I don't know why it is not maximum maximum equal. Yeah. Okay, so 1 0. Okay, so I'm doing it all. I want to start from the beginning, so I'm just gonna check for the BFS. Binary tree, so okay, I just want another one. So the BFS will be 1 2 3 4 5. Okay. So I just want to check for this. So function to print level order. If I equal root, then for range. So he's gonna print the two roots. Okay. And then he's gonna make a DFS, a recursive. So level -1, enter the level is 1. And what did he initialize level as? Okay. Let's just go with it. So then have to make all this. Okay, so def height, print current print root level. I'm not taking it copy paste like this. So his main function is print, so height equal high, and high will be, if node is none, 0, then L high equal the high. You do one return recursively, so if L high, I think this website is good, but sometimes it's trash, man. Pre-order, okay, so 01342. First route, it's BFS. Hey, hello mate, how are you? Okay, so we're gonna stick with the basics, okay? So if root, and then I'm gonna append it in a queue. I'm gonna make this fs self and root. And then I'm gonna just call it, so fs of root, and I should initialize a queue and make queue as a parameter, and queue, make a queue, and then queue dot append dot value queue, and then after all this return the queue. So self.bfs and this self.bfs, this self.bfs. Okay, so cute. Okay, so now we have 107 minus 8 7. Okay. What is this test case? Okay. I think I'm gonna switch them. Oh, there is no need to switch them. So this is the first level. This is the second. Okay, every time we're gonna make it, we're gonna add to the level plus 1. So this contains 2. I need to know. Okay, so this level has 2 elements. I need to note, so we're gonna do plus 1 and plus 1, and then sum the so if we have 1 and then 7 and then 0, so we're gonna sum those 2. But how are we gonna make it? Okay, then there is here 4, 2, or like pop the two element and sum them. But we have to make it in the end. So compare level sum with max sum at every level. Yeah. So we're gonna initialize two variables which are level sum and max sum. Okay, but how I'm gonna identify the level? So okay, I want to print here. I want to print Q. So okay, now we have 1 and then 1 0 and then 1 0 7. If now in this case we have to pop those. I think we need another function which is the sum, and we'll call it when we start another level. Or how we no, this is not because to sum every level, like I have to print 1 and then 0 7. Yeah, but I don't want just to copy paste this code. Yeah, okay, it will show me where it is. Where is it? No, this is not. Yeah, this thing. But I just don't want to copy paste it. Yeah. So this is good. So this is the first level. This is the second. This is the third. But I just don't want to copy paste it. I want to think it on my way. You see? So I don't really know how to make it. So level 1 will have max 1 element. Level 2 will have max 2 element. Level 3 will have max 4 element, which is this 2.0, 2, 1 and 202. Can I put every level in a stack? Okay. You have to return the maximum sum of any level in the tree. Yeah. So I'm comparing the max sum and the sum. But I want a. Can I make a queue for every level? I can't. So the lists are 117 107. So if the len of the list is greater than 1, which is in this, we're gonna sum it. Okay? Until we yeah. So I was explaining the problem to chat. Oh, okay. So I think we're gonna slice it like in this level, which is 107. We're gonna make it from this level, this which is 1, which is the level, to the end of the list. So we have to use that. Okay, I'm just gonna make a loop, and then we're gonna. So for and you have to remember the level. So I'm gonna make this level level 0. Okay, so level 1, and here level, here level. So for G in level, in range level, in range level, no, not the range level, in the list, in the queue, where I'm not using really queue, I'm gonna use a list. So for G in queue of level until the end, we're gonna sum it. So sum plus equal G. But for every level you have to initialize the sum to 0. Okay, and then okay, I'm just gonna compare it. If okay, sum 1, if max sum is greater than sum 1, then max sum is sum 1. Okay, so we know how do we know that we are in another level? If for every new level we have to initialize the sum to 0. Do you have to make a like previous level and level? Okay, I'm gonna test it for now. So print maximum, and here we have to make it also. So sum 1 and maximum, and here sum 1 I saw a tree tour in a subject, but I don't remember very well. Yeah, you're good, you're good. Welcome to me, by the way. So here it's someone, and here is Maxim. Someone, Maxim. Are you using recursive? Yeah, I'm using recursive. It's gonna pop an error, yeah. Okay, so this not, so someone and Maxim. And here makes sum 1 equals 0 and max sum equals 0. Okay, so what is it? Listen why required. Oh, level. Oh, okay, so level plus 1. For every one we have to increment the level plus 1. So level plus 1. Okay. Okay, so one. Why? What is this? Print, and why didn't he print it? If okay, so like this is good. Like this is good. Yeah, I am. Yeah. I think there is a like. Do I have to change the level for 0? Like, let's see. Oh, okay, so okay, so he's adding the sum, but he's not initializing the sum to 0 for every level. So the problem is here. The problem is in this condition. In this, what? No, there is no condition. Yeah, okay, so I have to add it. So I want to print the level also. So print level equal level to know how to deal with this. Okay, so level equals 0, and here the level equal 1. And here the level equal 2. Okay, so for every when the level changes, we have to initialize the sum to 0. So like if the level changes or the level is greater than, we have to put a condition on the level. How we know that the level changes? When we have the recursive thing. Okay, so I'm gonna pass here, it will be a long one, so I'm gonna pass here level, and then we're gonna pass here next level. Okay, Hmm. No, no, no. So, so in these two cases, the level is 1. If the level is the same, if the level didn't changes, then we're gonna sum, or can we just subtract? I want to make previous level. Okay, so the level here. Okay. So let's look at it one more time. So the level here is 1, and we have 2, which are and 1 0 set. So the length will be either 1 or either 2 or 3. And here the level is 3. I chat. It doesn't matter. I don't care how I'm gonna how much time I'm gonna consume in this problem. I'm gonna do it. I have to do it actually. I think of subtracting like, but in the recursivity there is no previous sum and next sum and. Hey, welcome stream. How long do you have coding? Do you mean? Hey, thank you, man. Thank you. Welcome stream, man. So I've been coding for like 1 year or 1.5. Okay. Okay. Now we're gonna do this. Get this shit out. So level 1. Okay. So level 1, then 1 to the end. Level 3. It's not 3 to the end. I want when the level changes. Can I pass previous level or? Okay, so I'm gonna pass a non-positional, I think it is. So previous level. Okay, so prev level equal level. But in this, Okay, can I do it like this? So priv level. Or I'm gonna make it previous. So previous it's level, and here if for G in level. Does this thing even okay? So so I have to print. I want to print previous level and level. So previous level will be BRV and the level. Okay, so hey, thank you, man. Yeah, it's the same thing. So the previous equal the man, this suck. This really sucks. There is one thing that I have to add to make this work, man. Can I subtract the, if you don't mind me asking, what web browser are you using? It's like Opera GX. Yeah, I know most developer use Firefox and that, but I used to be a gamer, so hey, thank you, man. Yeah, it is. Like, look at it, so beautiful, man. Okay, so not this, but this. This be the longest stream ever, so no, it won't be, but I'm just gonna think another for another trick, and if we don't get it, so we're simply gonna look to the chat. Is there a like a function that check if a pirate? Okay. Pre-change, post-change. This man. Okay, I'm just gonna ask a chat, not for a correction, but don't correct my code. Just tell me the missing part because I'm about to do it. So will not return any value from the BFS file, so any calculation related to max sum and sum 1 are effectively lost. Oh, okay. Are passed by value, meaning modification inside the function do not persist outside its scope. Okay. So, but use those return value in the max level sum method. Okay, so we have to return a value from this. Okay, so every time I'm gonna return the value of the level plus its max sum. Okay. Okay, don't want all this. Don't want all that. Return. Okay, so use those return value on the max level sum method. Okay. Okay, I can't do it anymore, so just correct it. So if not root, oh, if level, I don't know what is this. So if level, so if 2 is greater than the level 1 is greater than len q, so we're gonna append and q of level dot append root val. So if current and that current sum equals sum of q level and then max level plus 1. And he returned to it. This really sucks, man. I totally apologize for using those LLMs because I wanted to make it my own, man, because I was too close. This is so oh, and even the second test case is not working. Okay, so let's see a solution. So he used toil, yeah. So level plus 1, sum, while in range, sum plus not full, and then much more easier, man. So I think, okay. Okay, so. Good. So honestly, this stream doesn't go very well. Didn't go very well. Those two problem like were too easy, but unfortunately I didn't succeed to solve them. I think this is the end of stream. Thank you everyone. Hope this video. Hope you like this video. Hope this video is not only benefiting me but also benefiting you and pushes you to work more and grind more. Thank you everyone, and as usual, see you tomorrow. Every day is a video, so keep up the good work and good night.